Our next experiment is experiment on determination of Y parameter. Y parameters in the sense admittance parameters. So this one is completely opposite of Z parameters because Y parameters Y equal to 1 by Z. So these two are inversely proportional. Okay. So it's mean here in previous condition for impedance values, I mean Z parameters calculation purpose, we have taken open circuit condition, but here we are going to take a short circuit condition. In open circuit we got voltages are very high and currents are zero. That's why we are doing open circuit at second port side, in the sense that second port voltage is current is zero, and we are doing a open circuit at first port, in the sense I1 current is a zero. So simply, but here we are in admittance parameters calculation side, we are doing a short circuit condition. Current is very high, voltage is zero. It's mean where we are doing a short circuit, that side voltage is a zero. If suppose for example we are doing a short circuit at port 1 side, so V1 voltage as a 0, and we are doing short circuit at port 2 side, second side, so V2 voltage is a 0. Here also we have a two conditions. Okay, so we are calculating here current values, because in previous condition Z parameters condition we are calculating voltage values, but here we are calculating current values. We are taking source as a source calculation as a current value. So it's mean here I1 I2 equal to Y11 Y12 Y21 Y22 V1 V2, just like impedance replaced with admittance, and voltage place we are taking current place we are taking voltage, that's it. Okay, and I1 equal to Y11 V1 and Y12 V2, and I2 equal to Y21 V1 and Y22 V2. Okay, so this one equation 1, 2, 3. So from this here already I said where we done a short circuit, that voltage is 0. So first we are doing a short circuit at port 2 side, that's why V2 equal to 0. From that we got Y11 equal to I1 by V1 and Y21 equal to I2 by V1. And similarly, assume the input to be a short circuit. It's mean port 1 as a short circuit, in the sense that voltage is a 0 simply. So where we have done a short circuit, in the sense that place voltage is completely 0. So V1 is equal to 0. From that we got Y12 equal to I1 by V2, Y22 equal to I2 by V2. So this one is a theoretical diagram. So port 1 and port 2. So R1, R2, R3 are unknown resistances. So in first condition practical diagram we are going to take it here. Short circuit second port V2 is a 0. So this one has a short circuit condition, and here we are taking one ammeter to measure the I2 current, and here we are going to take one ammeter to measure the I1 current, and where we are taking power supply, that place we are taking one voltmeter to measure the voltage value. Okay, previously 2 voltage values we are measuring by using 2 voltmeters, but here we are taking 2 ammeters to measure the current values. Okay, so here this one has a power supply V1. So whatever the power supply we are connecting at port 1 side, so that voltage is a 9.9 volts, and I1 current we are measuring by using the first ammeter. Here this one is a I1 current, and by using second ammeter we are measuring the I2 current. Okay, from that we got Y11 equal to I1 by V1, Y21 equal to I2 by V1. Okay, so practically we are going to observe these values in practical diagram. So first I am going to connect here power supply. So for positive terminal of the battery, I mean first terminal of the power supply we are going to connect for positive terminal, and ground terminal is connected for negative terminal. Then we need to connect one ammeter here, that one has a I1 ammeter. First terminal is connected ammeter 1 first terminal is connected for first terminal, second terminal is connected for second terminal, and then next we'll go for ammeter in series with this short circuit condition place. Okay, you can observe these values will not change. Resistance 1 and 2 and 3. These three resistances will not change. Okay, then we will go to connect one ammeter at short circuit place. Where we are doing a short circuit? This side. It's mean second port side we are going to do a short circuit. So at this particular condition we are going to connect. So no need of this ammeter. That's why I am going to do a bypass here. Because we are not taking I2 current at this particular condition, where we are doing a short circuit, that place only we are going to take one ammeter. So first terminal is connected for first terminal and the second terminal is connected for second terminal of the short circuit place. Okay, so here first terminal is connected for ammeter first terminal, second terminal is connected for second port according to this practical diagram. Okay, and I am going to connect one voltmeter at power supply side to measure this one is a one multimeter at power supply side, where we are giving a power supply, that side I am going to connect one multimeter. Then I am going to turn on the power supply. Okay, you can observe here this one has a I1 current and this one has a I2 current and this one is a V1 voltage. So here I got V1 voltage as a 10.65 this time, but previously when I was connected circuit at the time I got 9.9 volts. It lightly variation. Previously here we got 87.87 milliamps at I1 current, but previously I got 88.4 into 10 to the power of minus 3. Previously when I was connected at the time I have taken that current as just 0.1 amperes. I mean to say that here 1 into 10 to the power of minus 3 milliamperes only variation for this time and the previous time. And here 67 we got it approximately I2 current, but here I2 current I got previously 66.7 into 10 to the power of minus 3. From that we got these values, y1 equal to I1 by V1 equal to 86.1 into 10 to the power of minus 3, 9.9 equal to 88.709 into 10 to the power of minus 3 ohms. Not it's mean this one is a admittance. Okay, and y21 equal to I2 by V1, that is equal to 66.7 to 10 to the power minus 3 by 9.9 equal to 6.743 into 10 to the power minus 3 ohms. Same like that we are going to connect case 2 also, but here second port side we are going to take a power supply and first port side we are going to connect one ammeter in seriously. So you remember here this one has a power supply we connected this one has a power supply we connected previously at port 1. That power supply I am going to connect port 2 side. Okay, and where we connected one ammeter now, so that ammeter I am going to just reverse it all the values, that's it. And no need of this ammeter, so bypass it. And the second I2 ammeter we are going to connect it first side, that's it. Then I am going to turn on it. Okay, same 9.60 previously when I was connected. At the time I got V2 voltage is 9.60 volts. V2 voltage in the sense where we are connecting power supply, that voltage is V2 voltage. That one is 9.60 volts. And I1 current is, which one is this one is a I1 current, because here the meter I have connected this one as a I1 current, so that one is 94.2 this time, but previously 98.3 into 10 to the power minus 3 I got, and here I2 is 62 approximately, but here I got 64.3 into 10 to the power minus 3. From that we calculated Y12 and Y22. We got it. Okay, so according to my practical circuit diagram I got these values, but exactly maybe your circuit having a different resistance values here, two-port network having a different input resistance, because that you will get a maybe V1 and V2 and I1 and I2 values are different, but almost according to theoretical formulas you are going to calculate impedance values and as well as admittance values. That's it. But in both the conditions we are going to measure the voltage and current values. So I mean when we are calculating impedance values, Z parameters values, at that condition we are going to do a open circuit condition. At that particular condition we are measuring voltage V1 and V2 voltage values. When we are doing a short circuit in admittance condition and I experiment, we are getting I1 and I2 currents. Okay, that's it. Then admittance values, I got it. Okay, and previously that formulas we written here. I11, I1, I2, Y11, Y21, Y2, Y12, Y22, V1, V2. These values we executed finally. These are the three measuring values.